Last week, I replaced the spark plugs on my 2005 Mercedes S500 with the M113 engine, as I have not replaced them since getting the car in 2022. While online sources tend to present a picture of considerable challenge, the work turned out to be only marginally difficult. The only tools I ended up using include a spark plug wire puller, a 1/4-inch ratchet with a T30 bit, a 1/2-inch ratchet with a 2-inch extension, a 16mm spark plug socket, and a torque wrench. The key is to put the spark plug socket with the extension in, but without pushing the extension onto the anvil fully. This way, the setup would be the right distance from the seat of the spark plug to clear the valve cover. In my case, the only problem I encountered was with the last spark plug wire on bank 2, closest to the brake reservoir. Number 8B, this one has the tightest working space, such that my plug puller could not get a grip. Eventually, I had to pry with a 17mm open-end wrench. Pressing that wire back on was equally difficult but possible with patience. The spark plugs are to be torqued to 28 Nm. I would have preferred not to use grease, but silicone grease turned out necessary for the wires to be pressed on with reasonable force. Before installing the coil packs and wires, I tested them with a multimeter. The results are rather enlightening. While all wires measured around 2000 ohms, 2 of the coil packs had already failed. To understand this, we need to have an idea of how ignition coils work. As far as I gather, a smaller primary coil closer to the iron core is connected directly to the ECU, while a much larger secondary coil is wound on the outside, with an insulation in between. The secondary coil has one lead going to the terminal on the spark plug, which is connected to the central electrode. When the primary coil is charged and then suddenly discharged, the collapsing magnetic field induces a high voltage in the secondary coil, which finds its way to the spark plug and central electrode. The primary resistance is that of the primary coil, while the secondary resistance is that between the lead of the secondary coil and the primary coil. Since a coil is a continuous copper wiring, its resistance is very low. In contrast, the 2 coils are insulated from each other, but a multimeter would present an ohms reading nonetheless because, as far as I understand, the coils are charged. This number is known as the secondary resistance. With Mercedes engines of this generation, the primary resistance is 0.3 to 0.4 ohm, while the secondary resistance is, in my testing, close to 7.8 mega ohms. In my case, the coils for cylinders 1B and 2A have secondary resistance approaching 0. This is symptomatic of a short between the primary and secondary coils. In such a case, the spark plugs connected to them would not fire. However, because the M113 and other Mercedes engines of this generation use dual spark ignition, the engine ran just fine. Fortunately, I had a couple of extra coil packs lying around. Now, if we examine the spark plugs that I removed, we can see that they are in decent condition. They are NGK platinum, similar to what I put in, but in a colder heat range. A rating of 5, like the ones I put in, is closer to OE and may reduce carbon buildup. Still, carbon buildup is light on these. On plugs from cylinders 1B and 2A and indeed 8B, we see some carbon on the tip of the central electrode, which could be a sign that they were not firing. Lastly, I have an endoscope and bore scoped some cylinders for wear. There was no visible mark, which is quite surprising given the car's 20-year age. I also removed one oxygen sensor and scoped the catalytic converter, which is as clean as new, even though every sensor and coil pack on this car was original from 2005. While this generation of Mercedes is regarded as ugly and electronically troubled, at least the mechanicals appear to be well engineered, well built, and easy to service.